let's take a look at just a couple of these here, real quick. How about this guy? Oh, let's get rid of that junk. Oops, wrong way. Okay, take a quick look at this problem here. This is one that seemed like we're having a little trouble with as a group. I'm just looking at one of the nice things about Moodle is I can just glance at an assignment and get a quick snapshot of where the class is. And this was causing some problems. This person did great, but it wasn't always that way. Okay, so how's that work? What do we have to do? Let me make this a little bigger so you can see it. When you're trying to simplify something like this, there's something that we have to remind ourselves about here, maybe. What do you think? Yes, sir?
Wait, so just solve it?
Yeah, if I wanted to simplify, I'm not solving, I'm simplifying. I'm going to try to make this into, just simplify it down to a single number. What am I going to do first and why? Okay, that's what you're going to do.
You would do the 3 squared, and that's what I would do first. I'd do 3 squared first, and then I would add down to negative 63.
Okay, that's a good start. Other suggestions? Yes?
Do PEMDAS.
Okay, PEMDAS, good. And that's what you're doing. That's fine. Let's write PEMDAS down. Always do that. On the test, first thing you should do on these questions is write down on your paper, write down order of operations in this way, right? So you remember which ones go together. Now, if we're simplifying, do we go top down, or is that regular or bottom up? I'm seeing some signs. Top down, yep, top down. Simplifying is normal. It's solving or isolating when we go bottom up. But this is just simplifying. So we got to do, what are we doing here? Well, we got to do parentheses first. Now, okay, there are some implied parentheses here. First of all, when you were dealing with fractions, and there's a bunch of stuff in the top and a bunch of stuff in the bottom, there are always going to be implied parentheses around the whole numerator and the whole denominator, always. Okay, so you always want to, in other words, you always want to get the top simplified down to a single thing, bottom simplified down to a single thing, and then when all is said and done, we'll divide, right? So that's given. So Ezra's idea of dealing with the 3 squared is fine. That's fine to do, right? We can, 3 squared simplifies to 9, and we're done with the bottom then, right? The bottom we can just replace with a 9. On the top, suggestion was to add 9 to negative 63 first. Now, why is that? Why is that? Why does PEMDAS tell us that? Yes?
Because the absolute value signs are meant to be parentheses.
Good. Because parentheses, excellent. Parentheses really, more broadly, P I guess just sounded better, but really that almost should have been a G for grouping symbols. Parentheses means any kind of grouping symbols, anything that's going to group stuff together, and absolute value bars are grouping symbols, so they count as parentheses, okay? So we have to work inside the absolute values first. Negative 63 plus 9 is what?
Negative 72. Wait.
No. Negative. How do I do that? Real quick, just quick review, going back like pre-algebra review real quick. If I'm going to add a negative and a positive, what's the quick little trick we can always do? Who can articulate that for us? How's that work?
63 minus 9.
Good. Okay, you always subtract the smaller number from the bigger number and then give it the sign of the bigger one. Yeah, in this case, negative 63. 63 is bigger than 9, so it'll keep the negative sign. But 63 minus 9 is 54. Make it negative, right? And then what does the absolute value bars turn around and do to that negative number?
Make it a positive.
Make it a positive. So ultimately what we end up with, when we break this down to just a fraction, is just 54 over 9, and that reduces, doesn't it? To 6. Make sense? Yes, sir.
Or another way for example, when you got 9, you could have completely divided the entire equation by 9. It would have made it a lot easier.
But I have to simplify the top first. I don't have a choice about that.
PEMDAS.
I have to simplify the top. I have to get a number on the top before I can divide by 9. Right? Is that what you're pointing out?
Yeah, but on this one, you could have just straight up divided by 9 because 9 goes into 9 1 times.
Okay, but now I'm gonna caution you there. That worked here, but you don't really wanna do that because the algebra and arithmetic involving absolute value bars gets tricky really fast. And so although it might have worked in this one case, it frequently will not work. And so what you wanna do is break that top down to a number first.
Yeah.
I promise you, because there are certain instances where that's not gonna work, I promise you. Okay, so don't overgeneralize that one. Okay, let me see if there's anything else on here real quick. All right, so use flashcards. But I'm not gonna review that one because it's really just memorization. So I'm gonna leave it up to you folks to.
Is the test Monday?
Test is Monday.
I won't be here.
Okay, when you get back. I mean, you can take it when you get back. Okay, what else? Okay, same kind of thing. That's another one that was commonly missed, just knowing those properties. Thanks. Okay, that one, it was missed just because I need to go in and give people credit for it because it wasn't working right. But people were fine on that one generally. Everyone knows what to do with that. Any questions on a problem like that? Right, where you're trying to simplify stuff? You okay with that? Just add up like terms? Okay? Okay, if I'm going to solve this inequality, now, question came up quite a bit on these. What do you do if you have three parts? Well, remind me, what do I do if I want to isolate that x? Okay, good. I can point to a single x so I can isolate it. I got to add 3 to all parts. Right? And what do I get? Well, the 3's cancel. Negative 2x, 8, and negative 2. Okay, good. So I haven't flipped them yet, but now I'm going to flip them, right? Now I'm going to divide everything by negative 2. Because I divided by a negative, I have to flip the signs around. So this becomes a negative 4, there's my x, and there's a 1. And then the last thing, this is probably the step most people have trouble with. Yeah. Did I get a sign wrong?
It's just crooked.
Which one? This one?
No, the other one.
It
doesn't have a line.
doesn't have the
Yeah.
line underneath it. The 5.
Oh, gotcha. Oh, I see what you're saying. Yeah, you're right. You're right. Thank you. So I need to, that doesn't have, good. So it's like that, right? That's what you're saying? Okay, now when I write this down, what do I have to do? Got to do the glass trick. Got to flip this whole thing around, right? Here's another way to think of it. I'm going to read this when the inequality signs are pointing backwards. I'm going to read it from right to left as I write it down, from left to right. So I put my negative 4 first, then I get negative 4 is less than x, less than or equal to 1. See how that worked? That's it. Okay? And I'd say that x is greater than negative 4 and less than or equal to 1. Okay. So far, so good. Let's see. Then maybe there's one more here, and then I'll let you go work. Okay. Here was a bad one. Okay, what about these? Let's look at these. Okay, phones away, or I'm going to collect them. Put the phones in your pockets. Totally away, please. We'll see. I mean, if you want to do more, we can, but I want to do at least one more. Okay, what do we do with these? Because this, I think people had some questions initially about what do you do with this? What's the question asking? But then, more importantly, how do we do the algebra to get there? Okay, now the reason I made these questions in this way for a specific reason, because this is how I want you to think of it. Yes, ma'am. Want to get started?
Yeah.
Okay. Okay, but before we even do that, now here's the part that I think some people are trying to rush into this and they're forgetting. Ozzy, what's the first thing we're going to do? Good. We want to make a trade. We want to make a trade, get rid of the absolute value bars and trade it for a compound inequality without, right? So the first thing I want you to do on these always, and that's why I made you do the problem in this order, is don't even focus on the numbers at all. First of all, you gotta realize what kind of a trade am I making? Which one of these 5 forms am I gonna trade for?
Number 4.
It's gonna be 4, isn't it? Because the sign of the inequality, oh, what happened to my, darn it anyway, this always happens. Darn it, darn it, darn it. There we go. Okay, because the sign of the inequality is that one. It's a greater than, an absolute value is greater than. That tells us immediately that it's 4, right? Not an and. And because there are no equal signs included with that inequality sign, we know that we're going to do this one, right? Okay, so that's the trade we're going to make. So let's make the trade. Now remember how the trade works. Whatever's inside the absolute value bars is going to be written twice with an or statement. Either negative 6x plus 4, because that's what's inside, is going to be really big and positive, so it's either going to be greater than 2, or negative 6x plus 4 is less than negative 2, right? So it's going to be very bigger than the positive or less than the negative, and I literally just solve them both. Okay, but watch what happens with this one. If I subtract 4, like I do, right, I get negative 6x is greater than negative 2, divide by negative 6, right? What's that going to make me do, though? Reverse the signs. So if I end up dividing by negative 6, what's negative 2 over negative 6? Hold on. Positive 1/3. Negative over negative, my sign rule says it makes it positive. So I just get rid of the negative signs. So I get a 1/3 and I have to flip that sign around. So there's part of the answer. Do the same stuff over here. If I subtract 4, I get negative 6x is less than negative 6. Divide by negative 6, so I flip the sign, x is greater than 1. So those are my answers. Now in the form of my answer, it says we want the a to be the left boundary. So a is the number that x is less than. Now if I had done these things and the less than part had ended up over here, it doesn't matter. That's still going to be a, right? So a is going to be in this case 1/3. Right, so in the box, I would just say a equals 1/3. What's b? Questions? Okay. B is the number that x is greater than, and so that would be 1. Make sense? Okay. Do we want to go through one of those that's an and?
No. Yes.
Okay, I think there's a couple. I think we should, and then that's it. I promise that's it. Okay. Let's. Last one. Yeah, I do. There you go.
Victoria,
Yes.
how did you get number 4 on the last question?
How did I get number 4? Oh, because it's an or. Okay, because it was a greater than with no equal sign included, so we know that's going to be an or statement. Okay, that make sense?
Yeah.
That's just something you just got to remember that part. Now this one, same kind of problem, only this is a little bit different because this one has the other direction of inequality sign, right? Okay, so on this one, because the inequality sign is a less than, it's an and. Right, we know because it's a less than, it's an and inequality. Those are the two of them that are joined together. There's no equal sign included, and so this one has to be a 2, doesn't it? Everybody see that? Okay. So then the question is, what's our trade going to be? That's the kind of trade that we make. Remember what our rule is on these. Whatever's in the middle just gets pinched between -7 in this case and +7, right? And all we do is solve this one just like we did that last one, right? And so really, once we get to here, it's like the old stuff, right? It's just like solving compound inequalities. Not that that's trivial, that's kind of hard to do, but I think if you can get to here correctly, it's all downhill from there. You got to make the trade first, though. Get rid of the absolute value bars. Make sense? Okay, we'll go practice. I have a new assignment up, too. Keep you busy.